Hello everyone. In today's lesson, we're going to demonstrate how to configure the Routing Information Protocol, which is commonly abbreviated as RIP. Our topology consists of three routers laid out in a triangular fashion, with each one of these routers being connected to the other two, and with each one of these routers being connected to a single PC. The objective of this lab is to configure RIP on all three routers so that every PC can ping every other PC of our infrastructure. I have already put in place the necessary infrastructure in terms of the devices needed as well as the cabling, and so what remains is to configure the network settings of each host and each node, and then configure RIP on the three routers. So without further ado, let's get started by configuring the IP addressing on the first host. We'll give it an IPv4 address of 192.168.1.10. Copy that and paste it as a default gateway with a .1 address. We shall do the same on the other PC. 192.168.2.10 with a .1 address for the default gateway, and then we will give the final PC an address of 192.168.3.10, and .1 will be its default gateway. Okay, with that done, we can go into the first router, type no, enable conft, and we will go into the Ethernet interface connected to the PC, which is 2/0. So 2/0, IP address 192.168.1.1 with a subnet mask of 255.255.255.0. We'll do a no shut, and then we will move on to the next interface, which is 0/0. We shall give it an IPv4 address of 10.0.12.1 with a subnet mask of /30, which is 255.255.255.252. No shut. Exit out of there. And the last interface of this router is 1/0. Like so, IP address 10.0.13.1 255.255.255.252 will be its subnet mask, and no shut. And we shall write our changes to memory and close the window of the first router for now. Moving on to the second router, type no, enable conft interface. Let's do the one connected to its local PC first, which is 2/0. IP address 192.168.2.1 255.255.255.0 will be the subnet mask. No shut, and then into 0/0 interface, IP address 10.0.12.2 255.255.255.252 will be the subnet mask. No shut, and finally, we will move into Gigabit Ethernet 1/0. IP address 10.0.23.1 255.255.255.252. No shutdown again. Save our changes, close the window, and let's go over to our third and final router. Type no, enable conft interface 0/0, IP address 10.0.23.2, 255.255.255.252 will be the subnet mask. No shut to bring it up. Next interface is 1/0. IP address 10.0.13.2, 255.255.255.252. No shutdown. And one more remains, which is 2/0. 2/0, IP address 192.168.3.1.255.255.255.0 will be the subnet mask. And we will run a no shut and write the changes to memory. Okay, so what we have done is we have configured the network settings for every one of our devices across our entire architecture. And therefore what remains to be configured is the RIP, the route information protocol on the three routers. So starting with the one on the left, we'll go back into configuration mode and type router RIP. We'll pick the second version of the protocol. And now we will specify the networks connected to this router so that we can advertise them to the rest of the infrastructure, to the other two routers. So the first network is 192.168.1.0. The second one is 10.0.12.0. And the third one is 10.0.13.0. Finally, a super important command to run when configuring RIP is the no auto summary command to force the router to advertise the exact subnets that we have specified so that it doesn't perform any route summarization. Save our changes. Exit out of there. Move on to the second router. const router RIP version 2 network 192.168.2.0 10.0.12.0 and then we have 10.0.23.0 and no auto summary. Save our changes, close its window, and we shall finish off by configuring RIP on the third router. So back into configuration mode, router RIP version 2 network 10.0.23.0 10.0.13.0 and 192.168.3.0 and then no auto summary, and save our changes. Close the window, fast forward the time, and if you wish to see the routing table of each router, you can run show IP route and you can see the routes being advertised by the RIP protocol because they're the ones starting with the letter R. Okay, so fast forward the time once more. And now in theory we should be able to have any one of these PCs ping any other PC of our infrastructure. So we will enter simulation mode, select ICMP as the only protocol and try to ping the PC of the 192.168.3.0 network from the PC in the 192.168.1.0 network. So let's see what happens. Okay, so we can see that the traffic is forwarded from one router to the other and the second router blocks it I don't think that this is something to worry about. I'm pretty sure it is a case of Cisco's packet tracer taking some time to process and apply our changes, our configuration in relation to the RIP protocol. In which case, all you need to do is to fast forward the time a couple of more times and then give it another minute or two and try once more. So same test again. Okay, we can see that the packet is going from one router to the other. Yeah, this time, as you can see, the traffic is not being blocked by the next hop router. The packet is arriving at the PC of the remote network, and that PC is sending back its ICMP echo reply, which is being forwarded to the initiator of the traffic, which is the PC of the 192.168.1.0 network. Great. If we delete that, okay, let us run another test just to be sure that everything is working as expected. So we will run a ping from the PC in the 192.168.3.0 network all the way to the PC of the 192.168.2.0 network. Okay, so we can see that the traffic is forwarded to the PC's default gateway, which in turn is forwarding it to the appropriate router, which indeed forwards the traffic to the intended host. The intended host is responding with its own ICMP reply packet, which makes it all the way back to the initiator. And there you have it. That's how we can configure the routing information protocol. Thank you very much for watching.